Hi students, welcome in this session. Today we're going to talk on the ozonolysis of substituted alkene. Mind you that during ozonolysis we can produce aldehyde, but also we can produce a ketone. So this can be produced under ozonolysis of alkene. So in order to produce a ketone, we have to use alkene, which is substituted at the carbon double bond. For example, if we take C double bond C, then R and R, this may be methyl or can it be any alkali group. Okay, so when this is subjected to ozone, we are going to produce the ozonoid of this nature, CO, then C, then we have R. So this is the ozonoid. Okay, then when we add water, these bonds will be broken. Okay, then this side will form aldehyde, by this side will form a ketone. Then the product will be CHO plus this now will form the ketone will be CR double bond O. Then also water will combine with the oxygen to produce hydrogen peroxide. Okay, as we have talked earlier that this aldehyde is easily oxidized by a peroxide. So now this will be oxidized to this peroxide will be oxidized to C double bond O, OH, then H. This now is a formic acid. So if we want to produce aldehyde and ketone, then we have to destroy this. We destroy this by using zinc in water, or we can use zinc in water, or we can use dimethyl sulfide. So now in this reaction we have to take this, the general reaction C then R plus, then the first stage we add ozone, the second stage we add water, but also the third stage we have to add zinc in water. This now will be the process will be under reductive ozonolysis. Then here we are going to get the product as this will form the aldehyde, this side will form the aldehyde, while this side will form the ketone. So it will be CHO plus CR. This is now a ketone. This is aldehyde, while this is a ketone. Then also zinc will combine with water with the peroxide which is formed to get zinc oxide, then plus water. So this now will be our general reaction. Then we have produced aldehyde and ketone. Why here the ketone is not easily oxidized by the peroxide, so it is going to remain as it is. While the aldehyde, instead of being oxidized, we have added zinc, then the peroxide will be oxidized or will be reduced by zinc in water. Then we get these two products, aldehyde and ketone. So now if we want to get both a ketone, then we have to use the both substituted alkene. Mean that if it is C, double bond C, then we have C here, then this is substituted here, then here we have it is substituted there, then and oxygen and ozone, then water, then here we are going to produce CR double bond, then there to this side also we shall form two molecules of a ketone. This is a ketone. So here there will be no addition of reductive agent because the ketone produced are resistant to oxidation. Thank you very much for listening. Keep on following me in this channel. We are going to learn better